Today's 2 Minutes of Science is all about ray tracing again. That's where we follow light beams to see how optical situations change. And today we're using a monocular. Just for reference, we're using a thick green laser so that when it goes through the lens you can see how the thickness of the beam changes. Well, now we're going to do the same thing using the monocular. Again, it's like a telescope, except it doesn't have the expandable joints that telescopes have. But it's something you can use with one eye to see distant objects. We're going to put the laser into the open end and see what comes out the eyepiece here. We'll add a little fog into the environment so that we can better follow the lines, ray tracing. Once the fog settles a little bit, so it's not so bright because of the green laser reflected off the base here, we'll be able to follow the lines of the laser. Now you'll notice that the exit laser isn't perfectly straight. That's because you have to line it up perfectly in order to make sure that the laser beam comes out straight. And just as a reference, what we're doing here now is we're running the thick green laser into the eyepiece and seeing what comes out the front. This beam out the front you can see is bigger than the thick beam, but it's even a bigger difference than that because the eyepiece itself is a fairly small aperture opening, so that means that only a portion of the laser is actually getting into the monocular. So coming out the front is a much thicker beam. So the idea again is the monocular is a light concentrator, and we've confirmed this with our ray tracing experiment.